Welcome to this explainer, where today we are cracking open the Cambridge Computer Science Examiner's playbook to demystify the commercial software licensing module. Look, if you've been studying for the 9618 AS and A-level exams, or any of the core Cambridge syllabuses like 0417, 0478, or 2210, you already know this subject is completely unforgiving. It demands a highly structured, almost ruthless approach to problem solving. I want you to think of this exam like a boxing match. It is literally you versus the paper, and the examiner is the referee. To win, you need to float like a concept and sting like evidence. Jab, cross, hook. These are your answer combinations. Now, I see two types of candidates all the time when grading these papers. First, we have Alex. Alex overloads every single answer with raw computer science facts. They throw 100 wild punches, but with absolutely zero strategic analysis. Then we have Sam. Sam rushes in, misses the command word requirements entirely, and gets knocked out by a technicality. Today, we are taking data directly from principal examiner reports to show you exactly how to structure your answers, avoid the traps that Alex and Sam fall into, and maximize your score.
Okay, let's dive into the stakes here. This single topic accounts for approximately 15% of your total marks in Paper 2. I really want you to think about that for a second. 15%. That is a massive chunk of your overall grade resting on just one specific area of the syllabus. That is literally the difference between an average grade and landing in the top percentile. We aren't just talking about vaguely memorizing a few basic facts about what commercial software is. We are talking about demonstrating a comprehensive, logical methodology that examiners are actively hunting for when they grade your paper with their red pens. If you just walk in there and try to wing it, you are leaving guaranteed marks on the table. But if you master the system we are about to break down, you are well on your way to a top-tier result.
To secure those marks, here is our fight plan for today. First, the 15% opportunity. Second, the core theoretical principles. Third, the procedural framework you must use. Fourth, critical examiner warnings. And finally, evaluation and analysis.
Let's start with Section 1, Core Theoretical Principles. We're starting here because Cambridge assessments demand a very specific type of logical, structured reasoning right out of the gate.
Now, what's incredibly revealing about this slide is that examiners are strictly prioritizing analytical depth over just knowing a little bit about everything. Think of your knowledge like an iceberg. The superficial breadth is just what's floating on the surface. This is where our student Alex usually gets stuck. Alex sees a question about commercial software licensing and immediately writes a massive paragraph listing every single type of license. Proprietary, open source, freeware, shareware, just a total brain dump. Jab, 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 jab. But there is absolutely no power behind it. The examiner doesn't care that you can memorize a dictionary. The academic benchmarks for this subject require you to demonstrate that you truly understand the architecture beneath the surface. They want the knockout hook. They want to see you dive deep into the why and the how. Why would a company choose a proprietary license over an open source one in the specific scenario? How does that choice impact their long-term scalability? That connected, conceptual understanding is the analytical depth that actually wins the match.
So how do you actually show that depth? Well, top-performing candidates anchor their answers by building undeniable combinations. This is where the Peel framework comes in: point, evidence, explanation, link. You have to start with precise definitions. That's your point. Then you establish clear causal relationships, meaning if A happens in a software environment, say a volume commercial license is purchased, it directly causes B, which might be specific deployment restrictions. That is your explanation and evidence. Finally, you seamlessly integrate that with other areas of the syllabus, linking it back to the broader system architecture. If you can show that connected understanding, you are demonstrating the exact mastery the examiners are looking for. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, the procedural framework. With the theory in place, let's look at how we actually translate that understanding into maximum points.
This is arguably the most crucial point of the entire explainer. You absolutely must understand the method mark strategy. In Cambridge computer science exams, you don't just get points for the final answer. You are heavily rewarded for systematically proving your algorithmic thinking. Think of the examiner as a judge scoring your technique, not just the final outcome. They want to see your step-by-step decomposition. They want to see the engine working, not just the car crossing the finish line. Even if your final conclusion has a slight error, maybe you made a tiny arithmetic mistake calculating license costs, showing a logical, structured process will secure you vital method marks. It's like showing you're working out in a complex math problem. If you just write down the final number and it's wrong, you get 0. If you show the brilliant process that got you there, you salvage the round.
And this slide brilliantly illustrates the exact standardized sequence you must use to guarantee those method marks every single time. This is your ultimate answer combination. Step 1. Deconstruct the question. Decode the command word. Is it asking you to describe, analyze, or evaluate? Step 2. Extract the relevant data. Pull the specific scenario details out of the prompt. Step 3. Select your analytical framework. This is where our time management matrix comes in. Decide how much time this question is worth and plan your PL paragraphs accordingly. Step 4. Execute your analysis with clear, readable notation. Do not make the examiner hunt for your logic. And finally, Step 5. Present your solution using the correct terminology. It is literally a roadmap for the examiner to award you full points. Follow these 5 steps and your answers will practically grade themselves.
Section 3. Critical Examiner Warnings. Because even with a great framework, principal examiner reports highlight massive pitfalls. Let's see where students bleed easy marks.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's look at mistake number 1, forgetting to check your overflow and edge cases. This is classic Sam behavior. Sam rushes through the exam, sees a question about deploying a commercial software license across a network, and completely forgets to verify what happens at the extremes. Just like pouring too much liquid into a beaker, you have to account for what happens when a system is pushed beyond its absolute limits. What happens if the company suddenly hires 50 new employees and exceeds their concurrent user license? That is an edge case. If you fail to account for these extremes during your testing and analysis, examiners will immediately penalize you. Always check your edge cases.
Building directly on that, the second most common trap is failing to rigorously check those critical boundary conditions. Let's do a quick mental workshop right now. Imagine a question states a commercial software site license covers exactly 100 to 500 machines. A rushed candidate will just write, "The license works for the company." But the examiner wants to see you test the boundaries. What happens at exactly machine number 99? What happens at machine 501? It sounds incredibly simple, but in the intense heat of an exam, students rush their step-by-step decomposition and forget to validate the exact boundaries of their logic loops or data structures. This shows a glaring lack of the systematic processing that top-scoring candidates are known for. Don't be like Sam. Respect the boundaries.
Finally, we reach mistake number 3, and frankly, this is the one that breaks my heart the most. Examiners warn that candidates lose massive marks when their answers are entirely generic instead of being specifically tied to the exact scenario provided. Let's say the prompt gives you a highly detailed scenario about a busy, metropolitan hospital needing a secure commercial database software. If you give a completely generic answer about software licensing that could apply to a local bakery or a tech startup, you get 0. None. Your answer has to be the exact missing puzzle piece for that specific context. You must pull the relevant data, the patient confidentiality needs, the 24/7 uptime requirements, and apply your fundamental principles directly to that unfamiliar hospital context. You have to fight the opponent in front of you, not the one you practiced with in the gym.
This brings us to a massive terminology alert. The principal examiner reports consistently reveal that candidates confuse key terminology. For instance, using open source and free software as if they are the exact same thing. They are not. You must always clearly define your terms before writing your extended response. Do not just assume the examiner knows what you mean, and whatever you do, do not use technical jargon loosely just to sound smart. Lock in your precise definitions right at the start of your paragraph. This is your opening jab. It establishes your credibility, shows absolute clarity of thought, and sets a rock-solid foundation for the rest of your argument. Now, I know this is a lot to remember under pressure. So if you struggle to recall these specific commercial licensing details, the source suggests using a visual story method as a memory hack to encode these complex rules. Don't just stare at a textbook trying to memorize dry facts. Build a vivid mental narrative. For example, imagine a tough security guard checking ID cards at the door of a VIP club. That guard represents your boundary conditions, checking exactly who is allowed in and who is turned away based on the license agreement. Visualizing the process as a physical story makes it so much easier to recall when the clock is ticking down, rather than just trying to summon a list of vocabulary words out of thin air.
Let's move to Section 4, Evaluation and Analysis. This is it, the championship rounds. This is where you prove you are a top-tier candidate.
To show true mastery and access those top band marks, you have to stop thinking like a student and start thinking like an evaluator. When you are looking at complex commercial software licensing, there's almost never one single perfect answer. Top-scoring candidates demonstrate their analytical depth by actively considering multiple solutions. You have to analyze the trade-offs. Sure, a custom-built proprietary software fits perfectly, but it costs a fortune and locks you into one vendor. You have to openly acknowledge the limitations of your own proposed solutions. And finally, you must justify your final decisions with hard, undeniable evidence extracted straight from the prompt. It's not enough to say, solution A is better. You have to say, solution A is better because the data on line 4 clearly indicates a strict budget constraint. That is how you land the knockout punch.
This all boils down to the ultimate formula for problem solving and software licensing. This is your complete computer science answering system. Step 1. Deconstruct the problem. Decode the command word and break the given information into logical steps. Step 2. Solve it systematically using the PEL framework, showing clear working and always checking your answers for reasonableness against those boundary conditions. Step 3. Evaluate your results to make fully justified recommendations based on the evidence. Deconstruct, solve, evaluate. That is the system. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCS and click that bell. Don't let another exam pass you by.
So as you head into your exam prep and sit down with your next past paper, I want you to ask yourself, are you ready to use this examiner playbook to absolutely maximize your score? Are you going to keep writing generic, superficial answers like Alex or rushing like Sam? Or are you going to step into the ring using the deconstruct, solve, evaluate method to prove your analytical depth? The playbook is right in front of you. Now it is time to put in the work. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.